Hey everybody, Sukanya here. Today we're going to be taking a look at how we can prove that these lines are coplanar. So we have showed these two lines are coplanar. So how do we first determine if two lines are coplanar? Well, we're going to see if it satisfies the scalar triple product. Essentially, the scalar triple product is essentially where you have a vector and you do the dot product of vector times cross product of another vector. So this is essentially what this means, and this has to be equal to 0. So the scalar triple product has to be equal to 0 for two lines to be coplanar. But how do we know what A, B, and C are? A is going to be the difference between the points the lines go through. So I'll explain that in a bit. And B and C are going to be direction vectors of the two lines. So let's start with this line first. This line passes through 5, 7, -3. How do I know that? I look at these numbers right over here in the numerator and I take the opposite sign of them. So that is what this line passes through. So it passes through 5, 7, -3. And the direction vector is simply going to be the numbers in the denominator. Now I'm going to do the same thing for this line right over here. I'm going to find the point the line passes through and the direction vector of the line. Alright, now that we have everything that we need, we're just going to plug all of this into this formula right over here. So I'm going to do P2 minus P1. And now in order to do the cross product, I'm actually going to use determinants. If you don't know how to use determinants, I have made a video on that previously, so please go check that out. Now that we found the cross product, I'm going to put it back in here. And finally, from here, I am going to do the dot product. And indeed, the left side is equal to 0, so we can say that these two lines are indeed coplanar using the scalar triple product, which is equal to 0.